Okay, for today we look at rule of inferences. Okay, last week we have seen quantifier. Quantifier, we have seen lots of quantifier for all, for some. Okay, so far do you have any question? Ada soalan ke untuk quantifier? Ada yang tak ni hantar lagi kat Padlet eh? Zaimizan dah hantar belum kat Padlet? Nota? Dah Bawa hantar. Wani bawa hantar malam tadi Wani? Hantarlah secepat mungkin, ni bukan untuk saya, untuk kamu juga. Okay, the rule of inferences is known as inferences rules. A logical form guide consisting of premises or hypothesis lah. Yang ni dia ada premises and hypothesis lah. Okay, wait Okay, boleh nampak ke? Can you see? Okay, this one include the premises and hypothesis. Okay. Okay, later we see that one in detail. Okay, in other words, argument is valid when the conclusion logically follows from the truth value of at all premises. Before this, we have take a look for the hypothesis and also for the conclusion. Okay, for the definition, a theorem is a valid logical assertion when can be proved by two conditions. First one is axiom, statement which are given to be true, and the second one is a rule of inferences. This one is based on the premises or hypothesis that I explained before this. Okay, this one deduction. Okay, and lemma is a pre-theorem and Colori is a post-theorem. This one we have pre and post. Okay. Okay, so far do you have any question? Is it okay? Okay, later we see what is a lemma, pre-theorem, and then this is a logical law, rule of weakening. Okay, rule of weakening, and then we have Colori, postmortem, which mean that rule for strengthening the conclusion. Okay, this one rule of inferences. We have H1, H2 until Hn, and then are the hypothesis. Okay, and then we use the conjunction, whereby the C is the conclusion, mean therefore it follows that. Okay, we have a hypothesis and follows by conclusion, and then uh, we conjunction. This one is the for some in the quantifier. We use the conjunction. Okay, this one is just addition for some rule of inferences. We have addition, we have simplification, we have conjunction, and then we have modus ponens. Okay, we have four here. One, two, three, four. Okay, later I discuss with you guys rule of inferences because this one is just the beginning of the uh, our topic. Okay, first one when we see for the addition P and P or Q this one is hypothesis divide by conclusion therefore we have hypothesis P implies conclusion okay implies conclusion P uh, this one is for conjunctive not conjunction for the addition okay. Okay, this one disjunction okay disjunction or addition also called introduction is a rule of inference propositional logic and almost every other deduction systems. The rules make it possible to introduce disjunction of logical proof. It is the inferences that if P is true, then P or Q must be true. Okay, from the hypothesis, P is true, uh, or Q, P or Q must be true. Okay, from the hypothesis. Okay, this one is addition. You need to do the disjunction. Okay. Okay, so far, do you have any question? Is it okay for disjunction? Okay, and then secondly, we go by the simplification in propositional logic. Conjunction. We have conjunction. Elimination, also called elimination N, or simplification. We simplified. Okay, here argument form and rule inferences which make the inferences that implies if the conjunction A and B is true, then A is true and B is true lah. And okay, okay, if the conjunction A and B is true, then A is true implies that P and also Q are true lah. Okay, this one is simplification. Okay, ada soalan ke? Do you have any question? Boleh ke? Okay, this one is simplification. You eliminate or you simplify. Okay, it's valid immediate inference, argument form, and rule of inferences which make the inferences that you conjunct the P and also Q, and then implies A is true, and then B also true lah. This one is number two, simplify, and then you have conjunction. Conjunction, as you know, for the conjunction, okay, you have hypothesis one, okay, and then you have hypothesis two, okay, implies the conclusion P and Q lah. Uh, this one is allow you to deduce the certain sentence from one or two others lah. For example, you can derive a conjunction by conjoining, or you merge together two sentences as a premises lah. Okay, you combine as a premises. However, there are some rules that are even more powerful than a rule of inferences, namely rule of replacement lah. Okay, for conjunction, conjunction, uh, derive a conjunction by conjoining two sentences or hypothesis. This one you need to combine conjunction or what we call it as conjoining. Okay, two sentences or hypothesis. Okay. Okay, and then okay, we have seen one and two, addition and simplification. Okay, and then the fourth one is modus ponens. In propositional logic, modus ponens, also known as modus uh, ponens, method of putting by placement. Okay, we replace it. Or implication, elimination, or affirming that antecedent is a deductive argument form and the rule of inferences. It can be summarized as P implies Q lah, is true. Okay, you need to what we call deductive the argument form method by putting the placement model that affirms. This one is placing it. Here we have one hypothesis one and hypothesis two. P implies Q. You simplify it. Okay, hypothesis one P, hypothesis two P also implies Q. And then when you have P and Q, okay, implies Q. Okay, you joining. Okay, you eliminate or affirming the antecedent. Antecedent mean before the uh, hypothesis. Hypothesis before that is a deductive argument form and rule of inference. It can be summarized as P implies Q, whereby P or Q. Okay, here is Q lah, because you replace it. You replace P. Okay, and then it is comes Q only. Okay, you eliminate P. Is it okay? You eliminate P. Uh, Here is a Q lah. Okay, by placing or eliminating eliminating. That is a modus ponens. Okay, so far they have four: addition, simplification, conjunction, and modus ponens. Placing or eliminate. Okay, so far do you have any question? Okay ke Atika? Atika okay ke? Eh, modus ponens faham tak? Dia placing by replacing the conjunction. Okay, we have H1, hypothesis 1 and hypothesis 2 is same, and then we replace. Okay, we eliminate. Okay, this one is modus ponens that we seen last slide, and then this one is modus tollens. We have modus tollens, hypothetical syllogism, and then we have disjunction syllogism. Okay, this one is replacement also. Okay, model stolen. Okay, as you can see, for modest tolerant, also known as removing by taking away. By taking away, for example, we have P, hypothesis 1, hypothesis 2, P implies Q. So we can say that the last output will be Q lah. Here, H1 is negate Q. Okay, and P implies Q implies negate Q. Then we deny the consequent and deductive argument and the rules of inferences. Model student takes the form of if P then Q, not Q. Okay. If P then Q is not Q. Okay. Not Q is P lah. Is different. Okay. You negate P implies negate Q, and then not Q is P lah. Okay. It's different. Is acronym. Acronym of modus ponens. Dia adalah berlawanan daripada modus ponens. Kalau modus ponens dia eliminate eliminate. This one is deny deductive argument that and rule of inferences. Removing removing by taking away. Okay. Here you can say this one removing. Remove by negation. Okay. Not P implies not Q. Okay. Not P implies not Q. Okay. And then not Q is P lah. Okay. Okay, and then the this one, 2, 3, 4, 5, 6. Number 6 five. Number 6 is hypothetically syllogism. Okay, this one is basically rule of inferences. You have many rules of inferences. Later in exam, exam you should apply this one. Okay, we have hypothetical. Okay, and then we have disjunction, disjunctive or disjunction or. Okay, we have P implies Q and Q implies R. Implies P implies R. Okay, we have hypothesis 1, P implies Q and then Q implies R. And then if we have the same element, you eliminate. You eliminate the same, okay, the same statement. Okay, in classical logic, hypothetical syllogism is a valid argument form with a conditional statement for one or both premises. As an example, in English, if I do not wake up, then I cannot go to work. Okay, then I will not get paid. Okay, this one is P implies Q, and then Q implies R. You just eliminate the same element. Okay, and then we have disjunctive or all. Okay, for the disjunctive rule of inferences, we have fourth rule of the 10 rule of inferences in propositional logic. Okay, we have 10 rules. Okay, this one is some of them. If you told that either P or Q is true, okay, and P is false, okay, then Q must be true. Then Q must be true. Here, P or Q, okay, hypothesis 1, and then hypothesis 2 is not P, and the last one is Q lah. Same goes to the P lah. Okay. Okay, example of disjunctive syllogism is either my pet is a dog or my pet is a cat. Okay, and then we have premises two. My pet is not a cat. Conclusion, therefore, my pet is a dog lah. Okay, disjunctive, or lah. Okay. Okay, for example, either my pet is a dog or my pet is a cat lah. Okay, and then premise two, it depend on the premise two lah. Okay, or hypothesis two, my pet is not a cat. Conclusion, my pet is a dog lah. Here we can say that P or Q, and then we have a not P is Q lah. Same goes here, P and Q, not Q is P lah. Boleh? For example, you are you taking discrete math and formal method. If you uh, do not take formal method, then you take the discrete structure. Same goes if you do not take discrete structure, then you take formal method. Ini yang ketujuh. Okay, then we have number 8, we have a resolution. Resolution. Okay, for the resolution, takes two premises in the clauses. You have P or Q, and then we have next hypothesis is negate P or R, and then here you should uh, resolving the two clauses X and X give the empty clauses. Okay, you have when you negate the P, you have P, both P, and then you eliminate okay, or resolve away. This one we call it as a resolve. You resolve. Okay, you have here P and P. Okay, and then we have Q or R. Okay. Okay, the resolution rule is a single valid inferences rule that produce new clauses by implied by two clauses containing complementary literal. Complementary literal. A literal is a proportional variable or negation of a proportional variable. We have a same variable there. Okay. Okay. Next is simplification. Simplification. You simplify. Okay, for example, here we have P. It is below freezing. Q, it is raining now. Therefore, it is below freezing. Okay, you simplify. Okay, simplified. We have discussed for the simplification. Okay, P and Q implies P lah. Uh, P and Q implies Q. Okay, N. Okay, either way lah. it will take the first hypothesis. Hypothesis. Okay. For example, if P it is raining now and it is below freezing, therefore it is raining now. Okay. It's either P or Q. This one. Okay. This one is simplification, and then we have modus ponens from the Latin modus that affirm. In other words, if the hypothesis is P is true, and the hypothesis P implies Q is true, then I can conclude Q lah. Modus ponens. Okay, modus ponens, you placing or you eliminate. Okay, P implies Q is true, then if N is greater than 3, it follows that N power 2 is greater than 9 lah. Okay, this one is modus ponens, you eliminating. Okay, exercise. If it's rain today, then we will not have a barbecue today. P implies negate Q. If we do not have a barbecue today, and then we will have a barbecue tomorrow. 3. Therefore, if it is rain today, P. Okay, then we will have a barbecue tomorrow. C. Okay, implies R is a conclusion. Okay, we have a proportional variable P. It is rain today. Okay, and then Q. We will have a barbecue today, and R. We will have a barbecue tomorrow lah. Okay. Step one is you need uh, to identify what is H1, hypothesis one, and hypothesis two lah. And then you go by the conclusion, hypothetical syllogism one and two lah. What is hypothetical syllogism? Ashikin ada, Ashikin ada, Ashikin, Ashikin tak ada ke? Ah, ya. Apa tu? Replacement. Dia nak replace apa? Ya ke? Betul ke? Kamu main game tadi? Habis? Saya terangkan tadi kamu tak ni. Tengok balik hypothetical. Okay. Okay, you remove the same element. Hypothetical. Here you have negate Q and negate Q as a hypothesis 2. And then as a conclusion here you eliminate this one. Therefore P implies R. Okay. 1 and 2. Hypothetical syllogism. Okay. Okay, and then for validity of an argument, if argument is valid, if whenever all hypotheses are being true, the conclusion is also true. Okay, valid. Make sure you have a hypothesis and conclusion. This one true. To prove that argument is valid, assume the hypotheses are true. and then use the rule of inferences and logical equivalences to determine that conclusion is true. Okay, they have two way here: a rule of inferences and logical equivalences. Okay, this one is just for reminder, important of equivalences. Recap, we have learned in chapter 1.2, we have identity, we have domination, we have idempotent, and then double negation. This one I will not explain anymore because I've explained in chapter 1.2 last 2 weeks. And then we have commutative, we have associative, we have distributive, and then we have De Morgan law. This one, okay, 8, okay. And then we have absorption, and lastly we have a negation. Altogether is 10. Okay, 10 of equivalences. Okay, that we have learned. Okay, for example, consider the following logical argument. If horses fly or cows eat artichokes, what is artichoke? Sazwana? Artichoke ni apa dia? Tak tahu. Artichoke kamu tak pernah jumpa ke? Amirul apa dia Amirul? Tak tahu artichoke. Aduh. Sayur lah. Bukan macam sayuran. Macam sayur lah tu. Then the mosquito is the national bird lah. If the mosquito are is a national bird, three, then peanut butter tastes good on hot dog, but peanut butter tastes terrible on the hot dogs. Therefore, cow do not need conclusion. Negate Q lah. Okay. Assign the proportional variable to each component in the argument lah. We have an assignment. Example P, horses fly, cow eat artichokes. We have four assignment here. 1, 2, 3, 4. Repeat the represent using variables. We have P or R implies Q, hypothesis 1. R implies S, hypothesis 2. Then we have a conclusion. Hypothesis 3 is negative S. And then the conclusion here is, as you can see, cows don't eat artichokes. As a conclusion, we negate Q. Cow doesn't eat artichokes for the conclusions. Okay, step 1, we have P or Q implies R, hypothesis 1. And then R implies S, okay, hypothesis 2. And then we have a hypothetical syllogism on 1 and 2 implies S, and then H3 is negative S. And then model stolen 3 and 4, okay, and then De Morgan on 5 and simplification on 6. Therefore, we have uh, lastly we have negate P. Okay, we have negate P. Okay, horses doesn't fly. Boleh? Okay, we have P or Q implies R is hypothesis 1. R implies S is hypothesis 2. And then negate S is hypothesis 3. Okay, and then lastly we have negate Q. Okay. Okay, for the reason we reason H1, H2, and then we have we do the hypothetical syllogism here. Okay, for this one. And then we have a model stolen on 3 and 4. Okay, we remove remove the S, and then we have a De Morgan law here, not P and not Q. And then we use the simplification. We simplify. Okay. Okay, lastly, we have negate Q. Okay, so far okay, Ashraf? Ashraf okay ke? Ni Ashraf ni. Okay, example, illustration ni. This one we look for the first condition. Uh, Bukan speaker, microphone, speaker untuk dengar lah, Ashraf. Kamu tak dengar ke, Ashraf? Speaker ke microphone? Dia pun pening lah. Rasa main game Ashraf ni. Okay, P or Q implies R is hypothesis 1, R implies S is hypothesis 2, and then we have hypothetical syllogism on 1 and 2, makes the hypothesis 4 lah. And then we have model stolen on 3 and 4, and then we have De Morgan law on 5. Okay, and then we have commutative on 6. Commutative law on 6, and then we do the simplification on 7. We got our conclusion of cow doesn't eat the artichokes. Okay, please look for the hypothesis first, identify the hypothesis 1 and 2. Okay, and then lastly, you do the simplification on 7, because the last assumption is cow doesn't eat artichokes. Okay. Here, show that the following argument is valid. Okay, this one is to prove. H only if C lah. The hypothesis only if the conclusion is true, whereby the R implies P lah. It is not sunny, P, not sunny. Okay, and then this afternoon, hypothesis 1, and it is cooler than yesterday lah. Okay, this one. Okay, is hypothesis 2. Okay, and then we go by the swimming R. We will go by swimming only if it is sunny. Okay, if we do not swimming, okay, we negate the R, then we will take a canoe trip. It is 4. We have 1, 2, 3, 4. And then S, if we take a canoe trip, then we will take home by the sunset. 5. Therefore, we will be at home by sunset. This one is conclusion. Okay, and then you go by the hypothesis. Okay, we have a P, Q, R, S, and T. It is sunny this afternoon. It is colder than yesterday. Q, we will go for swimming. R, we will go for canoe trip. S, we will be home by sunset. T. And then we have negate P and Q, H1. R implies P, H2. Negative R implies S is H3, and then S implies T is H4, and then we have conclusion T. Okay. Okay, then we identify the process. The process reason we have H1 and H2, and then we do the simplification on 1, and then we have modest tolerance on 2 and 3. 2 and 3. Okay, because we negate, and then for the 4 negate R, and then we have H3, and then modest exponent on 4 and 5. Okay, because we eliminate it's what we eliminate. Okay. Okay, and then H4 modest exponent on 6 and 7. Okay. So this one is a rule of inferences. Okay, for modest exponents lah. Okay, modest exponent which P is true, and if P implies Q, PQ, and then Q is true lah. Okay, same goes here. Uh, S implies T. Okay, whereby T is true lah. Okay. There are two logical argument when you ask how do you know if the argument is model exponent. There are two consistent logical construction model exponent that way that affirm by affirming and model tolerant the way that denies by denying. Okay, model exponent is affirming by affirm by affirming, and model tolerant is denying by deny by denying. Here how they are constructed. Model exponent, if A is true, then B is true, and then the conclusion A is true. Okay, here if you go by the tree simplification, and then we have model tolerant on 2 and 3. Okay, R P and Q, and then negate P and Q, and then we have R implies P, and then we negate on 1. Okay, and then we have modest tolerant on 2 and 3 comes 4 negate R, and then we H3 negate R implies Q, and then a modest tolerant modest exponent on 4 and 5. We affirm by affirming that is the proven that we want to prove again. Okay, that one is modest exponent. Modest tolerant is you denies by showing some denial of action. Okay, and then we have H3 and H4. Okay, hypothetical syllogism on 1 and 2. And then H2 is implication equivalence. Okay, and then we have hypothetical syllogism on 3 and 5. And then for 7, H1, hypothesis 1. And then simplification on 7 and model exponent on 6 and 8. Okay. That's why we have implication equivalence. R imply Q is equivalent to negate P implies negate R. That's why we have negate P implies T, and negate P we have as a conclusion is T. Okay, we eliminate this one. Okay, here we have a predicate, two predicate for all. Everyone in the discrete math class has taken computer science courses. And Marla is a student, D. Marla, in the discrete class. Therefore, okay, therefore, conclusion, Marla has taken computer science course as a conclusion. Okay, and then we have here dx and cx. Okay, this one is the predicate. Okay, that you assign the variable, and then the variable is marla lah. Okay, x is the discrete math class, and x has taken computer science courses lah. And then we have premises h1 and h2, and then we have c as marla lah. Okay, marla has taken computer science courses. Okay, we have using the premise, and then you have universal using one. Okay, C D marla implies C marla. Okay, D for discrete imply computer science, and then we have a premise, and then model respondent using 2 and 3. Model respondent using 2 and 3, and then you eliminate D, discrete by C lah. Okay, step by step there. We have for all dx implies cx as h1, and then d marla for h2, and then d marla implies c marla. This one is universal instantiation on 1, and then we have c marla is model respondent on 2 and 3. Okay, so far do you have any question? Okay, for the predicate logic, universal instantiation, also called universal specification or universal elimination, because we have model respondent, is a valid rule of inference form, true value about truth about each member of the class individual to the truth about the particular individual of that class. You want to instantiate the universal quantification for the predicates. Okay, or you can call it as a universal elimination. Okay, universal instantiation. Hold on. Is equal to universal elimination. Okay, that's why you need to use the model exponent. Okay, why? Because you want to affirm that by the affirmation. Okay, another is exercise. A student in this class has not read the book. Everyone in this class passed the first exam. Therefore, someone who passed the first exam has not read the books. Okay, and then we have fallacies. Okay, that resemble rule of inferences, but are based on the contingency that rather than tautologies. They are incorrect inferences. Three common fallacies. Fallacies ni some sort like ambiguity, ambiguity that affirming the consequences, denying the hypothesis, and in circular reasoning, begging the question. Fallacies. Fallacy ni some sort like you question why it happened. Okay, why it happened. Uh, Fallacies are common error reasoning that will undermine the logic of your argument. Fallacy can be either illegitimate argument or irrelevant argument and are often identified because they lack evidence that support the claim. Wait, I open and close up again. Stop sharing. Okay, so far do you have any question? Ada soalan ke? Syasha ada soalan ke? Belum. Okey ke? Boleh ke? Boleh follow ke? Senang je kan? Model stolen, model stolen. Okey. Ni Alip. Alip okey ke Alip? Senang je kan? Boleh. Okey. Jangan boleh je nanti apa? Exam tak nanti nak buat. Nanti saya ni lah. Kalau tak faham, if you don't understand for the exercises, later you should ask lah. Okay, fallacies Uh, basically, fallacies is a common error in the reasoning. Okay, common error in reasoning. This one is it can be affirming the consequence, denying the hypothesis, or circular the reasoning, begging the question because of lack of evidence. This one, incorrect inferences or common error in logic. Basically, this one is a lack of evidence. Okay, can I continue or you want rest 5 minutes? Do you want rest? Nak rehat ke 5 minit? Okay, kita we rest 5 minit